Okay, this is Dr. Williamson. I'm going to go over some dimensional analysis help for you guys. And dimensional analysis is using the units of a number to convert it into basically another number. Remember, all in sciences, all numbers have basically the number followed by its unit. For example, if you go to the doctor and you step on a scale and it says 145, you don't weigh 145, you weigh 145 pounds. When you put a baby on a scale, they would weigh the baby in ounces if it's a really small baby, or or pounds, like 9 pounds or something like that. I guess ounces would be too small, but it's the number and the unit. Okay. And we're going to convert our given number into the desired answer by using a conversion factor. And it's going to be the unit that solves the problem for us, not the number. It's the unit. For example, let's suppose I'm going to do a one-step conversion here. It means I have only one conversion factor. Suppose I want to convert 2.73 gallons, and I want to know how many liters that is. Okay. I'm going to go look on my chemistry conversion factors and constants chart that was posted in the announcements, or I could go look it up online, and I would see that exactly 1 gallon is approximately 3.78 liters. This means exactly, and this is 3 sig figs. Three sig figs. So now I'm going to take my given and I'm going to write it down here. 2.73, and I'm going to write gallons. GAL is the abbreviation for gallons. And I'm going to go times, and I'm going to put a line. Okay. Now I'm going to pick pieces. I got 2 pieces to my conversion factors. I got this piece, the gallons piece, and I got the liters piece. Okay. This has gallons already, and this is kind of like 2.73 gallons over 1. That's what that means. So what I'm going to do is I'm going to take this 1 gallon and I'm going to put it on the bottom of this fraction here. So I'm going to write exactly 1 gallon. And I'm going to take this piece, 3.78 liters, and put that on the top. Okay. Now I'm going to erase this. Okay. Now, when I multiply these, remember, kind of like in algebra, if I have A times B over A, the A's cancel out, right? Well, if I have gallons times liters over gallons, the units of gallons are going to cancel out. And I'm going to be left with 2.73 times 3.78 liters divided by 1. So when I multiply those, I go 2.73 times 3.78 divided by 1. And that's going to give me 10.3194 liters. If you leave it like that, you're actually wrong. Because this is 1, 2, 3 sig figs. This is 1, 2, 3 sig figs. And this number is exact. Whenever they give you equivalences that you look up, and it says one something is equal to something else, that one something is always exactly 1. So I know this is exact. So this is 3 sig figs. This is 3 sig figs. My answer must be rounded to 3 sig figs. So this is going to go 1, 2, 3. That 1 does not round the 3. So my answer is going to be 10.3 liters. I'm not going to leave it like all of this because this is 1, 2, 3, 4, 5, 6 significant figures. But my problem was only 3 sig figs each. My answer can't be more accurate than the numbers in my problem. So this is the correct answer. And this is called a one-step conversion because I had only one conversion factor. Okay. So let's try maybe a two-step conversion. Let me clean this out, right? And clear all that out. A two-step conversion will involve 2 conversion fractions. Okay, I'm going to make one up for the sake of teaching how to do it. And let's see here. Let's say I want to convert pounds into grams. Let's say I weigh sodium chloride and I have 0.73 grams. Oh, excuse me, not grams, but pounds of sodium chloride. And I want to convert it into grams. And I, for whatever reason, don't know a direct conversion between pounds and grams. You could actually look up a direct conversion between pounds and grams on the internet, but I'm showing you a two-step conversion. So, well, when I go to my chemistry conversions and factors paper, I know that exactly 1 kilogram is approximately 2.20 pounds. And I also know that exactly 1 kilogram is exactly 1,000 grams. These two are exact because that's part of the definition. So I'm going to take my given 0.73 pounds times conversion fraction. And I'm going to use this piece because it's got kilograms and pounds in it. I'm not going to use the bottom piece because it doesn't have pounds in it. This is the only one that has pounds in it. So I'm going to put 2.20 pounds in 1 kilogram. I'm not going to solve it. I'm going to show the second step. You have to do it this way. Okay. Now, pounds cancels with pounds, and I'm left with kilograms. I'm now going to use this piece. 1 kilogram is 1,000 grams. Kilograms cancels with kilograms. This is 2 sig figs. This is 3 sig figs. This is exact, exact, exact. So my answer can only go to 2 sig figs. So I'm going to take 0.73 divided by 2.20 times 1,000. My calculator spits out 331.818118 grams. And if you write that down as your answer, you're wrong. I can only go to 2 sig figs. 1, 2. This does not round to 3. So I'm going to write 3, but it has to be 330 grams, not 33 grams. So I need to put in a 0, a placeholder 0. I put the letter G for grams. And that's 2 significant figures. I'm not going to put a dot. If I put a decimal point, that would make it 3 sig figs. This makes it 2 sig figs. And that's my answer to 2 sig figs. Okay. You guys see how that's done? That's a 2-step conversion. We'll do some more later. I've got to get this uploaded, but you guys get the idea. Okay.